All right, so I thought for this lesson it would be maybe easier for you guys to see how you can go through and annotate your notes. So I'm going to fill your notes out just as your presentation today. So we are starting out with 5-1, 5-2. We're going to do it all in one day because they're so similar to our solving equations. But it's solving linear inequalities by using addition, subtraction, multiplication, and division. So essentially just one-step equations, but with those inequality signs. Now don't forget your inequality signs are less than, greater than, less than or equal to, greater than or equal to. And to get this pen, typically you're in home, I went to draw, and then you can pick any one of the pencils. I usually just get the marker, put it on the smallest, and pick whatever color is your favorite. So we have the addition property of inequalities and the subtraction property of inequalities. And what that says is pretty much what the golden rule of algebra says. What you do to one side of an equation, you have to do to both sides of an equation. So it's the same principle, except what you do to one side of an inequality now, you do to the other side of that inequality. So our first inequality here is to solve s minus 12 is greater than 65. So just like in an equation, I want to get the s by itself, so I'm going to add 12 to both sides. So s is going to be greater than 77. Okay? Pause the video, take a moment, try the your turn. All right, so let's go ahead and take care of this your turn. So we want to get k by itself, so I'm going to add 4 to both sides. So we get k is less than 14. So look, first two done already. All right, let's move on. Oh, one thing I guess I should mention, if you guys don't have a stylus and want to draw with your finger, you just have to click that draw with touch button, okay? And then unclick it so that way you can move up and down on the page. And look, there's also a little eraser. All right, so back to example 2. By 5 p.m., the temperature in Fairbanks had risen 23 degrees to a temperature that is now less than 14 degrees. What is the temperature at the beginning of the day? So since we're trying to find out what the temperature was at the beginning of the day, I'm just going to go ahead and say my temperature is going to be represented by X. So we don't know what the temperature was at the beginning of the day, but we know it rose 23 degrees. So that means it was plus 23 degrees. And now we know the temperature is less than 14 degrees. So it must have been pretty cold. So now if we go ahead and solve this inequality, so subtract 23 from both sides, 14 minus 23 is negative 9. So we know the temperature was less than negative 9 degrees Fahrenheit. So again, pause the video, try the your turn, then come back and double check yours. So in this problem, we have x plus 15 is less than 13 if you go and read through the problem. So when we subtract 15 from both sides, we get x is less than negative 2. All right, so there's two very short story problems just to show you that it's really no different than the others. For example 3 now, it says solve 12n minus 4 is less than or equal to 13n. So we're getting into variables on both sides now. But we solve it the same way we have solved anything. So if I have 12n minus 4 is less than or equal to 13n, I need to get my variables all on one side. So I'm going to subtract 12n from both sides to get my variable on the right-hand side. So we get negative 4 is less than or equal to 13 minus 12 is just 1n. Now, we do have to graph this, and I know some people don't like to graph it with the variable on the right. If in your previous classes they told you to look at which way the symbol was going, and that's the direction you shade, I must tell you that that only works if your variable is on the left. So we need to switch this around, because right now my variable is on the right. So if I put my n on the left and my negative 4 on the right, we need to say, okay, I'm probably going to have to switch my inequality symbol, because if you look at it right now, it's open towards the n. So I need to make it so that it's still open towards the n. So that's what it looks like. Now on your number lines, when you graph this, I don't need like an entire scale from negative 100 to positive 100 with every unit in between. I just want you at least have to have the number that's in your inequality. So I at least have to have negative 4. And then put a value to the right of negative 4. I'm going to go ahead and put 0, and then value to the left of negative 4. I'm just going to put like negative 6. And now this is where you can use the highlighter if you want. That feature is pretty nifty, actually. I think I'll do that. So I'm going to use my highlighter. Let's do that light lilac color. The greater than or equal to symbol. I'm going to come back to here because we need to remember some things. Remember, if we have less than or greater than, that is an open circle when we graph. If I have greater than or equal to or less than or equal to, it does not like to write on 2 different pages. Anyway, that one is a closed circle. Meaning I don't shade in or I shade in. One way you can remember this is if it takes more ink or more time to draw the line underneath, you need to take more ink, more time to color in the circle. All right, so now going back to example 3. We are going to put a closed circle at negative 4. So I'm going to color it in, and then it says it's greater than negative 4. So larger numbers always go to the right on the number line. So there's my graph. All right, take a moment, try the your turn, and then come back and double check your work. All right, so hopefully your turn turned out like that, where you have p is less than or equal to negative 6. So a closed circle at negative 6 and everything shaded to the left. All right, so we have only done addition and subtraction. We haven't had to do any multiplication or division yet. But there is something really, really big if you do multiplication and division. It's the only thing that makes solving these inequalities different from solving equations. So if you multiply or divide by a negative number, okay, so that means the number you're multiplying by or the number you're dividing by is negative, you must flip or switch, however you like to think about it, the inequality symbol. Right, so if you had a less than, it will now become a greater than. If you had a greater than or equal to, it will become a less than or equal to. And that is only if you multiply or divide by a negative number. So example 3, we have negative 3/5 d is greater than or equal to 6. All right, so there's 2 ways you can do this problem. Some of you prefer to do this in 2 steps. Some of you will want to do it in 1 step. I will do it both ways. So the first way is if I want to get rid of the 5 in the denominator. So I'm going to multiply both sides by 5. So my 5's cancel and I'm left with negative 3d greater than or equal to 30. Now notice I put the negative with a 3, so that's why I didn't flip the inequality symbol yet. And now if I want to get rid of the negative 3, I have to divide by negative 3. And as soon as you think the words or say the words divide by negative, you know right away you need to flip that inequality symbol. So we get d is equal to 30 divided by negative 3 is negative 10. Right, so that's the first way you could solve it. Okay, the second way you could solve it in 1 step is we know that if I have 3/5, negative 3/5 times d, what's the opposite of multiplying by a fraction? Well, dividing by a fraction. But dividing by a fraction is the same as multiplying by its reciprocal. So that means I would need to multiply by negative 5/3 to both sides. My 3's cancel, my 5's cancel, 2 negatives make it a positive, so I'm left with D. I multiplied by negative, so I need to flip that sign, so it becomes D is less than or equal to. And now I can just multiply my fractions straight across. 6 times negative 5 is negative 30. 1 times 3 is 3. And then negative 30 divided by 3 is negative 10 again. So we got the same answer no matter how we did it. So take a moment and try the your turn. All right, so for this one, you should get x is less than 30. All right, next example. Example 3, we are flying right through this, almost finished today. So solve the inequality. So we have 12s is greater than or equal to 60. So if I want to get s by itself, I have to divide both sides by 12. Wait, do I need to flip the sign here? We do not actually need to flip the sign because we divided, but the number I divided by was positive. So it was a positive 12. So 60 divided by 12 is 5. So s is greater than or equal to 5. Now for part B, we get negative 8q is less than 136. Divide both sides by negative 8. Are there bells, whistles, fireworks going off in your head? Oops, I accidentally wrote an equal sign. Because we divided by a negative, which means we need to flip the sign. So q is now going to be greater than 136 divided by negative 8 is negative 17. All right, so take a moment, try the 2 your turns. I'm just going to work through those quickly and then double check your answers. So for A, you should get P is less than 4. And for B, you should get, what did I forget to do? I forgot to flip my inequality. So X is less than negative 16. All right, last example. It says Alicia wants to buy season passes to 2 theme parks. If one season pass costs $54.99 and Alicia has $100 to spend on the passes, the second season pass must cost no more than what amount? So let's think about this. She wants to go to 2 different theme parks and she has $100 to spend. So we're going to have the cost for park 1 plus the cost for park 2, and she has $100. So I need to put some type of symbol in there. So we need to think, can she spend more than 100? Does she have to spend exactly $100, or can she spend less than $100? So we can put, sorry, I'm not really sure why that keeps going back to the top. If she has $100 to spend, if one season pass costs $54.99 and she has $100 to spend, the second season pass must cost no more than what amount? So we're actually going to put less than or equal to, because if she has exactly $100, she can spend all $100 of it. So now we're going to say one season pass is $54.99. So I'm going to put $54.99 for park 1. Plus, we don't know how much park 2 is, less than or equal to $100. So if we subtract $54.99 from both sides, we are left with X must be less than or equal to $45.01. So if that second park pass is $45, she's good to go. If it's $45.02, she is just a little bit short. All right, so again, pause the video, try the last your turn, come back. All right, so the last your turn, it says Michael scored 30 points in 4 rounds of the free throw contest. Randy scored 11 points in the first round, 6 points in the second round, and 8 in the third round. How many points must he score in the final round to surpass Michael's score? Now that surpass means something huge. We don't want it to equal Michael's score, because if it equals it, then they've tied. He wants to win this. So we have to add up all of his points. So he scored 11 points, plus 6 points, plus 8 points, plus the last round, we don't know how many points, and that actually has to be greater than 30 points. We don't want to put greater than or equal to, because again, if it ends up being equal to 30, they ended up tying. So 11 plus 6 plus 8 is 25, plus x is greater than 30. Subtract 25 from both sides. So Randy must score more than 5